So here we're going to use the idea of the global warming potential, and we're going to be reading from a graph. So again, skills of reading from a graph, using this potential, etc. So it says if a farmer applies 80 pounds of nitrogen per acre per year, what are the pounds of N2O, which is nitrous oxide emissions per acre? So I just read from my graph. I'm going to go fertilizer rate is 80, and as I go up to 80, and then I go across, again, I'm going to make sure I'm reading from the line. I'm going to say 1.3, 1.4. Again, it's not going to be perfect. You might argue 1.25. That's fine. So I'm going to just say 1.4 pounds of N2O per acre. Again, you might be a little bit different based on how you read the graph, and that's fine. So now, question 4 says, a farmer applies 120 pounds of N of fertilizer per acre per year on a field of 200 acres. What are the pounds of N2O emissions? And then what is the global warming potential of this gas? So I go to 120, so I go 120, I go up, and then as I go over, looks like I'm going to say about 1.5, probably 1.6. So I'm going to say 1.6 pounds of N2O per acre. And that's for every 1 acre. So if I do it with a ratio for 200 acres, how many pounds of N2O emissions? And if I do this, I'm going to find about 320 pounds of N2O emissions. But N2O has a greater global warming potential than CO2, so I want to know what its global warming potential is. So this is where I go back to the previous page and I find the warming potential for N2O is 265 times that of CO2. So I'm going to say here, actually I'll just change my pen color, and I'm going to say the 320 pounds times this 265, because it's 265 CO2 for every 1 N2O. And from that, I kind of shortcut this here, but I get 84,800 pounds of CO2 warming potential. So again, the gas that is emitted matters too. Last thing I'm going to do is I have a word problem. I got to extract some conversion factors from this, okay? And it talks about the combustion of 1 short ton of coal, which is 2,000 pounds, releases 7,500 pounds of CO2. So if a farmer applies 140 pounds of fertilizer per acre, how many pounds of N2O are released? How many pounds of CO2 is this equivalent to? And then the combustion of how many tons of coal is this equivalent to? So my first thing is to go ahead and I'm going to start with 140 pounds of fertilizer. So I go 140, go up to my graph. When I come across here, looks like it's about 2. So I'm going to say it's 2 pounds of N2O emissions per acre. Okay, and he applies this, they apply this to their farmland, and their farmland is 500 acres. All right, if it doesn't, I think per acre, and it's 500 acres. Okay, 500 acres, which is going to give me 1,000 pounds of N2O. Then I'm going to use this warming potential, okay, for every 1 N2O, it's 265 CO2. That's the global warming potential from the previous page. And so when I multiply those together, and again, I don't think it said here, so it should say in here her farmland. I'll note this in here. It is 500 acres. So if you're like, where did that 500 come from? It should be included in there. I think it might be in your copy, but you're not seeing it on my screen. So when I multiply all that together, I'm going to get this total warming potential, this 1,000 times 265,000 pounds of CO2. That's going to be the warming potential. So how many tons of coal combustion is that equivalent to? So I can use my for every statements here, or I can use a ratio, or I could use a conversion factor. The choice is yours. But it tells me that the combustion of 1 short ton, so I'll say 1 ton of coal, releases 5,700 pounds of CO2. So when I do this as a conversion factor, again, ratio or for every is fine. I'm going to end up with 46.5 tons of coal. So combustion of fossil fuels is a big problem. But again, this the fertilizer application releasing this nitrous oxide, because of its greater global warming potential, has some serious implications too.